Indian Railways is deploying its first fully indigenous hydrogen-powered train, officially named the Namo Green Rail. The system replaces diesel combustion with hydrogen gas, eliminating carbon emissions entirely in favor of a clean water vapor exhaust. The physical and mechanical architecture was executed entirely domestically. Two primary nodal agencies split the engineering and manufacturing responsibilities under the Make in India initiative. This map details the production nodes. The engineering blueprints were developed by the Research, Design and Standards Organization, or RDSO, located in Lucknow. The physical construction was then carried out by the Integral Coach Factory, or ICF, based in Chennai. While India has already electrified massive stretches of its railway network, overhead wiring is highly impractical in certain geographic terrains. Hydrogen technology provides a self-contained power source, allowing trains to traverse complex routes without relying on continuous external grid infrastructure. The initial layout features up to 10 passenger coaches, capable of carrying over 2,600 people. To support this load, 3 separate coaches are strictly dedicated to housing the hydrogen storage, fuel cell systems, and control electronics. Inside the fuel cell, stored hydrogen gas reacts with ambient oxygen. This generates electricity to drive the motors, outputting pure water as the only byproduct. To supply this, 54 high-pressure hydrogen cylinders are evenly distributed, with 27 at the front and 27 at the back. During trial runs, this system achieved speeds between 85 and 110 kilometers per hour. The engine setup delivers nearly 1,200 horsepower and has currently been tested to maintain a range of 250 kilometers on a single fueling. The overall efficiency is augmented by a regenerative braking system. When the train applies its brakes, the kinetic energy is captured and routed back into the onboard battery bank, preventing immediate power waste. Instead of passively drawing power from an overhead wire, the train actively synthesizes its own electricity on the move, operating as a zero-emission power plant. This map shows the external infrastructure built to keep these trains operational. India's first dedicated hydrogen plant for this project is being constructed in Jind, Haryana, engineered with a 3,000 kilogram storage capacity. The plant produces fuel through electrolysis. Electrolysis is a process that uses an electrical current to split water molecules into separate hydrogen and oxygen atoms, allowing the facility to extract pure hydrogen gas directly from a water supply. By producing fuel at strategic local nodes, the railway solves the supply chain problem for isolated track sections.
Trains refuel at these localized hubs and complete long-distance trips through terrain where stringing overhead electric lines is structurally prohibitive. Traditional steam and diesel locomotives operating on steep, high-altitude routes release dense particulate exhaust into fragile mountain ecosystems. Replacing these legacy engines directly cuts localized air pollution in these specific environments. To address this, the government launched the Hydrogen for Heritage initiative. The mandate specifically targets tourist corridors, deploying these clean trains across historical and hill routes like Kalka-Shimla to maintain the tourism industry while halting the ecological damage. This infographic breaks down the financial commitment behind the rollout. Indian Railways has officially allocated a 2,800 crore rupee budget to manufacture and deploy 35 of these hydrogen trains in the current phase. This specific railway initiative is directly tied to the country's macroeconomic climate strategy, specifically the mandate to achieve a net zero carbon economy by the year 2070. By domesticating the engineering, manufacturing, and local fuel production, the Namo Green Rail creates a self-sustaining cycle. It reduces the national reliance on imported fossil fuels and lays the practical infrastructure for a broader green hydrogen economy.